Good day from our clients from around the world. And this is Engineer Clarence Vincent I. Reyes from Solocorn Valley. And I am the Chief Network Engineer and the Security Analyst here in our company. And today, I am going to discuss our network topology. But first, we are going to dive in to WAN topology. So before we go further, what WAN topology in our company does, sorry. First, I'm going to discuss to you what WAN topology is. So WAN is a wide area network that provides network communication services in the workplace, connecting locations that can be spread anywhere in the world. So a topology is a description of a layout or arrangement, and applying the concept of topologies to WANs involves two different but interrelated perspectives. So one perspective is consider the physical topology, which, for example here, that describes the physical arrangement of network devices that allow for data to move from a source to a destination network. And another perspective is the logical topology, which describes how data moves over the WAN. So this is a perfect example on which I will describe later on what this WAN topology does in the Roque Roaño building, or the engineering building here in University of Santo Tomas. And here, I'm going to discuss first the four types of WAN topologies. First will be the flat topology. This is a small company with few locations might implement a flat topology. So this uses design point-to-point circuits between the physical locations forming a loop. So next is the star topology, which involves a central location involving central location serving as the hub in the design, with the sites branching off the hub like spokes on a wagon wheel. So in a star topology, a failure to one hub location will not affect the other sites on the WAN. And next will be the full mesh topology, in which the full mesh relies on every site's one router having a connection to every other site on the wide area network. So full mesh topology provide a high degree of dependability and fault tolerance, which can come at a high price tag. And this is one of our main issues here in creating a WAN topology, partnering with Cisco. So we are limiting as much as possible the use of budget that is so high that it might compromise the whole budget of the engineering building. So we are avoiding any expensive and not so useful kind of arrangement here in our design. So, and last will be the partial mesh. So it is like a full mesh also that involves partial mesh topology. So this introduces a hierarchical approach to the topology that can be applied when designing international networks. So this would be somewhat an example of a partial mesh. And now I'm going to discuss to you our WAN topology. And this topology is using a hierarchical three-tiered network design, so which was recommended by Cisco. So the topology requires three main parts: the core layer, which is here in the center, the distribution layer here in the bottom part of our topology, and the third one would be the access layer. So in the distribution and core layer, the distribution layer aggregates the data coming from the core layer to the access layer and vice versa, while the core layer allows all data to go in and out of the system and provides fast transport between the distribution switches. So this would be the distribution switches. And for last, the access layer disseminates the data from the distribution layer to the end devices of the network. So this layer can be this can be comprised of hubs, switches, or routers. So this composed of all the hubs, switches, or routers that can be or that can be configured by us so that it could be more fast, reliable, and more efficient in distributing all the data. So here, I also forgot to mention the distribution layer also dictates the policies and guidelines of the campus or enterprise. And here also, lastly, before we move on to our next topology, the teleconference and the data center room are directly connected to the core layer for faster communication outside the network. And our next topology would be our LAN topology. So before we explain it further, let me introduce first what is LAN topology. So a LAN physical topology defines the geographical arrangement of networking devices. So topologies are driven fundamentally by two network connection types. So first is a point-to-point connection, is a direct link between two devices. So for example, when you attach your computer to a printer, you have created a point-to-point link. In networking terms, most of the today's point-to-point connections are associated with modems and PSTN. So PSTN is a public switch telephone network. So communications, because only two devices share point-to-point share point-to-point connections. It defeats the purpose of a shared network. So in a LAN topology, we are going to be discussing our design. So first, in our LAN topology, the LAN network which was designed makes use of access routers. So this is an access router which is connected to the distribution switch. This distribution switch would now be placed in every floor of the Roque Roaño building. And the switch can be used in order to increase the number of end devices that can connect to the LAN network. So our end devices will include an office computer, student's computer, professor's computer, and the admin's computer, depending on the client's needs. So I'll be, let's say, on my own personal account of what will be the required end devices for the engineering building. I would be easily be doing that because of the distribution switch and the access routers that I am configuring, and I am placing here in the Roque Roaño building. So in the next topology that we'll be discussing will be our best design features. And here, our best design features for the Roque Roaño building. And first, our best design feature would be our wireless routers are installed in each and every floor, and with that, there is full scalability. So if administrators would want to put up more access points to the internet to every floor, is like plug and play. So it would not be a hassle for them to access all the access points to the internet. So if there is a connection problem, there would just be disconnecting it and connecting it in order to gain access to the internet. So it would not be a problem or it wouldn't be complicated to access internet points for the administrators. So for the second best design features of our proposed project is our teleconference hall and data center is installed in the first floor of the Roque Roaño building, so which is directly connected to the core layer switches of the WAN for faster data communication. And our third and fourth best design feature for our proposal would be from the ISP to the modem and also to the main router. Fiber optic cables are used which will deliver a faster internet connection between LAN networks. And the fourth one will be access routers have built-in Wi-Fi or LTE capability. So we want our proposal, we want our whole building to have reliable and faster internet connectivity, and it will be covering all of the building floors. So if there is a out of reach internet connection, it would not be a problem for our proposal because we would have more access routers and our main routers, and from the ISP to the modem will have our fiber optic cables. So we are using these fiber optic cables even though we have discussed that it would be raising the cost of our proposal. It would be, in return, it would have a faster internet connection between LAN networks. And our fifth best design feature for our proposal would be 5 up to 10 Gbps internet connection is provided by the company, which is the Solocorn company, and it would be distributed to all of the building here in Roque Ruano. And our sixth best design feature would be shown in the next video. And in this sample representation, this is the proposed upgrade of our AVR and our data center. So as you could see at the right would be our telecommunications room, and in the left would be our data center upgrade proposal. So this is our overall best design feature for our company, Solocorn Valley. And thank you for listening. And this is Engineer Clarence Vincent I. Reyes. And see you again soon.